Hello, I'm John Walker. I'm the head of security research at BeyondTrust. I was going to talk a little bit about using open source identities or IAM tools and kind of some methodologies borrowed from DevOps to improve how we do identity management when it comes to, especially cloud and cloud native applications. So I said already introduced myself. I'm John Walker. I think that kind of had been in the industry for I guess a couple of decades at this point. I think my entry point to security, was kind of being young. I think kind of like roughly at the era when dial-up kind of BBSs were kind of ceasing to be a thing, and kind of got interested in the offensive side of things. Got me interested in computers and all that kind of fun stuff, and that ultimately led to jobs doing computer programming, system administration, a bunch of things that were not security. And then those things eventually led me around to doing software engineering work, doing DevOps work, IT administration for security companies, helping the people to build security products, and then all the way back around to doing the security stuff that I started with. Currently kind of focusing on offensive security and identity security, helping BeyondTrust build out our kind of leading the building out of our identity security insights product. So brief background about me. I think one bullet point I was really wanted to make sure to put on there was that I'm not an AppSec professional. I think the last couple of years I've been really focused on identity for reasons that will come out in the other slides, but I think it's like the centerpiece of all domains of security right now, and one of the areas where we have the biggest opportunities to make gains. And I also wanted to share that worked on this presentation with some colleagues at Entitle that couldn't be here to give the presentation, but I think both with Entitle and Insights we're really, first of all, we're building products ourselves, and we're trying to think about how do we keep these things secure. And when we do that, we're trying to think about our products, open source things, like we have to do this in a scalable way, but also in the back of our minds kind of thinking about like, well, what ultimately as we analyze customer environments, what are we going to try to tell them to do when it comes to application security things, or like anti-patterns to call out, all that fun stuff. And I think, critically, not really at a point where I feel like, I can say like, here's the recipe for doing this right, And I think the purpose of this talk is not to try to share a recipe or anything like that. It's more as someone coming at this from very much a DevOps perspective, identity security perspective, and, exploring application security is is the identity aspects of it, especially as we try to build out, cloud native applications and scale. Here's some kind of things I've learned so far. Could be things that are all fairly obvious to everyone here. It could be things that, doesn't quite actually seem super useful to me, but just kind of almost kind of like sharing the work in progress as far as where we are, as a companies, BeyondTrust and Title, discovering how to do this ourselves and think about how to help other people do it. So kind of long intro there, but I think starting point for me, the reason that focused on identity, I think I already touched on it, but I think it's the one unifying abstraction, identity privilege, policies that control access to these things, that kind of spans all the domains we have to cover. And it's both like the concepts and abstractions span, and then often actually identity literally spans in the sense it's the same accounts with SSO, or if it's maybe technically different accounts, like an AD account and an Entra account, but practically speaking, pretty much essentially the same identity. And so, very critical as our environments become more splintered, more heterogeneous, that we have the things, the conceptual abstractions, and then the literal, ways that these all things connect. So one reason I think identity security is a key to a lot of things. Another reason is the kind of controls we can place on identity are kind of context-driven controls that can be aware of things of like, here's the person, it's not just an IP address, here's the person trying to perform this action in this application, here's their current employment status, here's the time of day, where that person works. Here's the ISP the request is coming in from, and here's the one that that person typically uses. Should we allow them to exercise this privilege and that sort of thing? So much richer, more flexible controls with more context, and I think we have the access to these controls exactly at the time that network controls, other controls like that are becoming less useful. So for those reasons, many other ones, I think for me, identity is kind of the center of a lot of things, the place I'm kind of focusing. And when it comes to the cloud, I think we kind of see what happens when identity is not done right? And I think that that is a lot of the reasons why, keeping applications secure in the cloud is a challenge for us anyway, something we had to figure out. And I think not just us. It's really kind of trying to boil it down, because I think I started, with this slide with literally, I think 20 bullet points worth of complaints, of my experience of working with primarily IAM and AWS and Azure, but just like, this doesn't work, that doesn't work, this is a pain, just pain points, pain points, pain points. And as I thought through them, I think like what these all add up for me is then what I do IAM in the cloud. It's not a repeatable process. That's the work I do in one AWS account can't even be applied to other AWS accounts in my same organization sometimes, let alone to other companies, other people when I go elsewhere. It's not scalable, right? Very manual often. Lots of art to it, lots of tuning, know-how, things like that that require, you require large investment of people and time, and don't scale to kind of rapid movement, larger sets of things and all that good stuff. And it's not scientific in my view, often, right? I think, and when I say scientific here, I mean a particular thing where it's not like, here is the set of things we are doing, and intend to do. We know that we are doing these things. And here's our theory about how we change those set of things to improve our security. Let's actually apply those controls and test that theory over time and see if it's correct and continue to evolve, right? That deliberate evolution, like moving with intention, understanding what we're doing, choosing to do the next thing for a reason, understanding the hypothesis we're testing by, say, constraining controls a little bit further in a certain way, and then validating, the result there and kind of adding that to the body of knowledge. And I think that extends to the community as well for reasons I'll go into, where lots of great work being done, but we aren't necessarily quite at the point when it comes to IAM stuff of there being like a unified body of knowledge about some things. But so long, a bit of a rambling thing there, but those are like, if I go through my 20 pain points with cloud IAM, they all add up to those. Some examples of the specific ones are, if you look at, or maybe the specific ones or the reasons, I think some of the key ones that add up to this situation, I think one thing is like actually the development of the exact sort of DevOps methods. I think I'm very interested in applying more to IAM, right? If you look at developers working on code now, they're kind of like cyborgs, right? They're automation assisted. More and more, they're finding ways to apply automation, programmatic analysis to ensure quality, and to let them move faster and faster and faster when it comes to application development, right? So feature velocity is increasing. It doesn't feel that way often developing things, but if you look at the industry as a whole, over 5-year time scale, velocity continues to accelerate. Businesses like that, right? But often on the IAM side, at least I find myself, it feels like to apply the rigor, we need to apply to reduce risk. That involves, reducing, velocity, never going to be something that sells for the business. And then just a few other things there, then in passing, I think one is just that there's not kind of a shared conceptual framework. Things like people are coming up with these things like the Microsoft enterprise access model for thinking about things like assets in terms of control plane, management plane, data plane. People are starting to come up with the formal frameworks and mental models, but not really widely accepted, not universal ones. And again, it goes back to this: every cloud is unique, every company is unique, every account in every cloud is unique, and you got to kind of bring a lot of know-how, expertise, figure out each thing in kind of like a one-off way. It's not quite that putting it that strongly, but and that again, that goes back to making things not repeatable, scalable, scientific, all that stuff. And so I'll skip through the rest of these, but they all add up to the same sort of thing. Maybe I hit one other one just with complexity and fragility. All these cloud services have exploded especially over the past 10 years. Lots of innovation, lots of reacting to what the market wants. Inevitably, though, that kind of tends to create systems that are kind of emergent, right? They weren't designed with understandability, maintainability in mind. And so we're at a point where they are very complex, very fragile, lots of foot guns. And so we're kind of at the place now of, as people administering these things, how do we, lots of ways we can make a small mistake that costs us in very big ways, hard to kind of, reason about those things. I think that was worth it to get these cloud services that we have, but we are still kind of maturity-wise, kind of goes along with the frameworks, goes along with a lot of these things. The fact that they're, we're kind of at a place where it's still early on in the maturity curve, and I think that relates to, can make cloud kind of identity administration in the cloud a bit difficult, a bit unscientific, a bit labor intensive. So, finally getting to the meat of it a bit here. as we've kind of worked on insights and entitle, as I said, kind of trying to think about and experimenting with trying to solve some of these problems, and especially when it comes to application security, because especially as a security company, if our stuff gets breached, then we lose customers, essentially, potentially all our customers. And I think just skipping right to the takeaway, I think that the thing we found to be most successful, and as we talk to people in the AppSec, world and in other worlds, to kind of eliminating some of these cloud IAM challenges, making our applications more secure at the identity layer, is ultimately to apply the kind of tested principles from DevOps to managing identities, to view the IAM layer as a piece of each of our applications, right? As part of our threat model for each application, and something that's managed scientifically as much as is actually possible with rigor, with DevOps principles, essentially in the same way that we do the code quality control, those things, right? Because then, as there are advances in how we do code quality control or DevOps for code, and that allows codes to accelerate, or coding to accelerate, future development to accelerate, this means that the governance that we're applying to identities also accelerates, right? Because it's benefiting from some advances. So basically, very simple thing. I think a lot of other people playing in this space right now, Microsoft doing some interesting things here, but basically, I think the thing we've found so far is basically just take those DevOps techniques that are handling all the complexity, these multiple clouds, all these things, and allowing software developers to move faster than they ever had before, and take them and apply them on the IAM level so that we also can move at the same speed of the applications using the identity layer. So pretty basic thing there, but I think it's been very, very powerful for us. And I think that I'm going to go through some tools that I think we found so far that allow us to do this, some methods as well, that allow us to do this or have so far. I think I'm not saying these are not the only tools that exist, but some useful ones from our exploration so far. But they're all of them kind of stem from basically a couple come from that place of trying to apply these principles to this new area. And that's why I think so we could get to the list of tools next, but I think kind of going through these things beforehand, just I think very clear to me, in general, there's no tool in the world currently that will make us magically secure. There will never be a tool that makes us magically secure unless we go to full autonomous AI-driven security or something like that. Maybe we get there, but currently, the things that make us secure, humans with expertise, applying tools in kind of a conscious way. And so, I wanted to start before the list of tools with here's the, I think the methodology or some of the, a couple points of context about how to apply the things that we're running through that were valuable to me at least. I think one is, playing with identity threat modeling or threat modeling in general. I think that's always the starting point for me in any security domain. You have to understand what the things are, how they're connected, how they're going to be attacked. Because you can't, if you don't have that, what are you going to defend, right? And how are you going to justify any investment you make in defense? Literal investment or just time investment and anything like that. So, and what I found, at least when I made threat models and looked at some threat models that other people made, kind of focusing on cloud applications, is they often didn't have IAM pieces and identity pieces in there that more and more to me felt like these should be critical things. They're almost like the core part of the attack tree being defended or the the threat model here. So I'm just going to walk and I think this exercise doing this then makes all the going through the tools. It's kind of kind of explains the approach being taken and the tools being selected and that sort of stuff. I'll go through quick an example of what I mean with the threat model here that includes identity things. I'm going to do it. Just have a quick threat model using attack trees. It's a technique that I like for visualizing threat models like this, pioneered by Bruce Schneider in 1999, so 25 years ago. And I was mentioning in passing that I love papers like this where it's just as relevant today as it was in 1999, right? And that's because it's addressing kind of the timeless principles at the heart of security, right? It's not the trivia that changes kind of day to day or year to year. So just a random plug for this paper here. And probably everyone's already familiar with it, but the attack tree kind of method to doing threat modeling is you start with a tree, a graph that's a tree like this. Your root node is an attacker objective. So here, we're hypothetically defending a safe, and the attacker wants to open that safe, right? Level one underneath that is a way, immediate steps they could take to open the safe. So they could learn the combination as an obvious one. And then we go down to level 3 and say, what are the things they could do to learn the combination, right? They could, get the combo from a person. They could find it written down, and so on. So it kind of maps the paths back from attacker objectives, to concrete things they might do. And then you can get super sophisticated with it, expressing like, what's the feasibility of these things, which ones have to happen together and stuff like that. But I think works really well for thinking about some of these identity or some of these threat models, a bunch of identity pieces. Another quick piece of background to get out of the way. So the threat model I'll show is kind of for this hypothetical application, very common, simple kind of cloud native application, 2 services, front end and a back end. The front end is web interface. The back end pulls data from both a database and a blob storage. We'll just stipulate that some of that data is sensitive, right? The whole thing runs on Kubernetes, right? So each one of these 4 components, or potentially is in a pod or something on Kubernetes. They have an identity issued by Kubernetes, critically like issued as in handed to them by Kubernetes, and via some mechanism, like there's a secret store at Kubernetes, for example, that could hand these workloads secrets they could be using to authenticate and those sort of things. And then finally, all this stuff is actually existing in the cloud somewhere. Kubernetes might be managed EKS. The database might be an RDS Postgres instance. The buckets might be S3 buckets and so on. And critically, the identities, every piece in the top, the logical application has an identity and privilege, and that identity and privilege is allowing it to talk to these other pieces, right? Or it has identity access controls and that sort of thing. And ultimately, that identity and access control stuff actually, kind of like the version of it, or the core version of it, lives on that cloud level, right? The identities live there, and kind of like the core access controls and stuff like that. And so those are not actually, they have huge impact on my application. Involve the design, architecture of the application, all these things, going to be considering those things, but they exist at the kind of cloud level and even above there, kind of on the theme of, partly kind of relates to the theme of like identity running through everything, right? Often a kind of unifying thing. So hypothetical architecture, a million applications like this. Here's, simple attack tree, kind of addressing, trying to think about how someone might try to in some way manipulate this application to steal sensitive data, right? And I haven't even really fully filled it in, but there's just some basic things there. Like, well, one kind of step to do that is to somehow steal from the DB directly, steal from the bucket, steal from the memory of the application, and we could just start listing thousands of techniques here, right? Of like particular ways, I might try to, for example, exploit the front end and get code execution or something like that and do this. But for the purpose of this exercise, just including some of these kind of IAM and identity-related ones, for reasons will be, identity-related ones. I think like 2, that are worth kind of commenting on, like this steal AWS creds from GitHub repo. Still, the overwhelming the way that most people get breached in the cloud is nothing fancy, it's nothing complex. Like, I forget what the percentage is, literally like 80% or more or something like that. All that happened is that someone found a GitHub repo, an environment variable somewhere that had an AWS token in it. They downloaded the AWS command line kit, command line thing, plugged in the token, listed the bucket, stole the data, right? That's just a very basic reality of like what happens in the cloud. I think it speaks to the level of maturity that we're at, right? It is just basically often steal the credential, plug it into the thing, download the data. And as it relates to this application, you can think of all the things we could do, to prevent remote code execution in the application, to prevent all the fun, more sophisticated techniques. They're all really kind of useless in a lot of ways, when the primary where people actually breach these applications today overwhelmingly is just to find the credentials, log into the control plane, kind of going back, log into this bottom layer using the identity and bypass the entire application, right? And that's kind of the point, I think, with all 3 of these, 3 of these kind of yellow ones here are all these kind of identity-based attacks, leveraging the control plane. And often the defense is, very relevant to the application security, but often the defense involves things like constraining the way that identities are provisioned or privileges provisioned. A simple thing that I've seen in production, for example, we steal the AWS creds from a GitHub repo, say, or we see this one compromise another service with overly broad DB creds. Not at all uncommon, actually, for a service to get a credential to talk to a database. They're using it to connect to one database, but actually it has the privilege to access more than one databases, right? So you're thinking of your threat model as you must breach this one block of code here to access the database. But actually, because of overly just imprecise kind of IAM controls. In fact, what the real threat model is, they must breach one of the applications running in your environment, and there's, let's say, 50, and any one of those can breach every other database, right? Just because of a simple often accidental, accidentally granting too much privilege to the identity that's accessing the database. And same thing with those, AWS creds and GitHub, right? Like, I mean, shouldn't be using tokens in general, probably, but your threat model really is like, where are all the places that this token exists? What controls exist on people who can get it? What controls exist on preventing it from being shared? All those things, and those controls add up to more than anything else to see, like, given the realities of how things get breached, to see, for determining whether your application or anything else is actually secure. So I think no great surprise here. I think like the lever that I see or have found and believe to be kind of the key to starting to, I think with the first thing here, like thinking, the first piece of the kind of method pieces for applying some of these tools is making sure to think about identity, the IAM threat, kind of threat pieces in the threat model. And then critically, for me at least, like something like CI/CD that allows kind of governance of IAM through DevOps types processes for all the reasons I think I've kind of touched on. Allowing, I think it's critical to taking that understanding of how IAM and the security of a particular application kind of connect, and making sure that we're governing and reviewing kind of the identities that provisioned, the privileges that get created, with an eye on application security in a way that's actually scalable and keeps up with developers. And essentially just governance, right? But it's critically not, a lot of kind of like, let's have someone manually look at every, change that's made in, every privilege change, every user change, right? I don't know. I think a lot of people have moved beyond that, but not everyone necessarily. That's time consuming. There's a lot of risk involved. People are often really wanting to kind of cover themselves, make sure they've done their due diligence, right? And there's a tendency just to move very slowly with the changes in policy, the changes to user privilege. There's also a tendency to add privilege and not remove it, right? Because if no one ever complains about having too much privilege, people often complain about not having the privilege that they need, or like an application not having the privilege it needs. So in general, I think the thing that I found to be useful is checking in actually like the code that controls the users that exist, their policy assignments into source control. And then using those, kind of like encoding the invariants that I want to be true about privilege to keep my application secure. So a simple one might be like an S3 key coming back, should only have the scope to one bucket, right? Like you can't create a policy that creates an S3 key, key to access AWS with S3 permissions that's just a star, on all buckets, right? Or for any policies that grant database access, we want to put conditions on the IP there, right? And we want to say you can only actually use this user if you are from the subnet that we expect, or whatever, from the range we expect our applications to be, right? And so those are invariant with kind of a CI/CD based approach. I can think about that threat model for my applications, think about those IAM pieces, put in kind of scientific controls in the sense of like, I think that by reducing, in general, establishing kind of the policy that if something has a RDS access, there's going to be the only way to do that in the environment is to create a condition in the policy that says it must be coming from an IP we expect an application to be in, right? And then encoding that policy in code such that if you try to change the identity infrastructure to make that not true, the build fails, right? Someone gets alerted, whatever. But so you have a kind of a body of invariants, when you're doing your threat modeling and stuff, and you see that like, okay, here's the threat that here's the thing that like the database credentials could be stolen, and someone could steal that data, could exfil the data in some way, kind of referring to those like identity invariants that are enforced by code there, and saying like, well, okay, so we at least know that because of these identity invariants, the only way that DB creds are going to be stolen, it's only going to be these DB creds. There's only the ones associated with this application, and there's like a smaller range of ways that could happen. So for thinking about posture, monitoring, and things like that, it makes the job easier. So potentially a kind of lengthy introduction there about the general methodology or how we're kind of coming to these things on our side at Beyond Trust, and then just kind of jumping in real quick to the tools here. We'll start with AWS ones, then Azure ones, and then some just general things. but kind of focused on kind of applying some of these DevOps principles to identity security with an eye towards keeping applications secure. So very simple one, AIR IAM. Simple but powerful. If we're going to take a CI/CD based approach to identity in AWS, we have to get that identity and infrastructure as code, right? Because that's the whole thing. Like you want a change to privilege to be a PR with all the process of a PR, so you have an audit log, so you can put the automated checks on it and so on. So AIR IAM, at its most basic level, it's a thing that'll migrate from an existing, take an existing AWS account, create a Terraform module. But critically, it has some pieces to it that make it so that you can actually do that at scale over and over and over again, not in a kind of one-off way. Because I think that I think my first reaction to finding out about this was like, well, now we're just going to take all the mess that's existing in, for us, about 300 AWS accounts, and we're just going to put it all in infrastructure and code, and no one is ever going to look at it. But we're going to think we're more secure because we're using Terraform, right? But critically, it has a bunch of controls and mechanisms for doing things like code cov checks or parliament checks on the policy that's getting created. So you can sort of, let's say you're running this on account after account after account to get that initial Terraform you need to set up your repositories and start controlling things in this way. And you can set up things like if code cov finds a like star policy, just a sweeping grant of everything, like actually don't just automatically create the Terraform, notify a human to come fix this policy before you do that. That does some interesting things. Least privilege recommendations we use a bit less because we use other things there, but also like if they don't really have like any kind of RBAC-y kind of thing set up, like users aren't grouped in groups that capture a role and privileges assigned to them, you can actually kind of guide it to, like we say, like here's like the 5 kinds of user groups I'm trying to create and assign users to, and kind of give it some guidance, and it'll actually assign users to these groups, attach the privilege to these groups. Sounds like a very small thing, but if you're going through many, many accounts with many, many users in them, just kind of really helps like get the stuff not just in Terraform, but in Terraform with just enough of the basics to be kind of much more governable. So kind of talking about AIR IAM first, because first piece there of for us anyway, like or for us, for other people, kind of getting stuff out of like not ad hoc created things in AWS, but to code and in a repo. Another great one that kind of then builds on that is Parliament. Basically think of it as unit testing for your AWS policy with all the flexibility of unit testing. So you can make, like the equivalent of, every time so you have all your policy and source control, every time policy changes, you're essentially applying these unit tests. And these unit tests can say things exactly like no one gets access to this bucket, right? Because that's where the really sensitive data for this application lives. Or if a policy grants access to it, these conditions must exist. Or it must be this type of a user. Great kind of like Python-driven syntax for the audits. And then critically, like with anything like this, there's sort of a community of people building audits and policies already. So you're not really just starting from square one. You have like a base of things to build on. You have people to collaborate with and discuss kind of what you're doing, right? And there's a kind of community of practice there. So AIR IAM to get the stuff into Terraform, into source control, Parliament running in the tests on that source control whenever policy changes to kind of start to establish some invariants, right? So that must be true about the policies, based on the threat model, kind of like the things that core things that you kind of want to be true. IAM Live kind of one I'll just touch on briefly, more of a tactical thing in some ways, but very useful. Can run an application that uses, say, Azure API calls and that sort of stuff. Run it, do whatever you want with it, and then it'll tell you actually exactly what it actually used, right? So hugely useful. There's, I think, one kind of important caveat with it, which is, you, of course, like depending on how you exercise the application, you might not actually, of course, exercise all paths. There might be privilege that that it does need that you're not necessarily finding, but you can often like. For us, we often kind of like, here's the sweeping privilege that it has. Like after using it for an hour and hammering all the endpoints, like here's the privilege that it used, and those things really don't add up, right? And so you kind of want to then hand check before, do some more checks before removing the privilege and automate, completely. But at the very least, useful for kind of regular, just kind of sanity checks, that sort of thing. I'm not sure. I'm sure people are doing more with it, but. Very handy for inspecting like what actually happens from a privilege perspective with a particular cloud application, such that we can see if there's the privilege it has, or the privilege, the identities it controls are reasonable, or like are the policy controls we have around it reasonable? Like, should we actually have policy controls that say this thing doesn't need S3? Let's just deny it from accessing S3, because that's just another thing an attacker can do if they get code execution, right? So let's run it through here. Does it use S3? No. Okay, so that's actually informs our policy, decisions and governance decisions there. Let's just outright deny these, kind of services that can be problematic from a lateral movement perspective and that sort of thing. I think that was kind of running through, I think, some things on the AWS side. Critically, the thing to kind of get the code in source control in Terraform, in this case, Parliament as the engine, for the engine for some of the basic kind of unit tests you might want to use for governance of the policies that exist in AWS, and then things like IAM Live for analyzing, like, what's actually happening with these applications. Can we afford to have more policy controls? Like, do these things have the privilege that they really should? And of course, all that stuff has to be paired with all the kind of sensible processes and all that sort of stuff, right? Around how that policy gets evolved and all that sort of stuff, or how like the tests, the automated tests you do need to apply to the policy and things like that. And I think that, to me, that's where most of the work is with these things. The tools kind of get you off the ground, and then there's a lot of thinking about those sorts of things. But some core ones there, and then then I guess moving to Entra, similar set of tools. It's interesting, I think, because AWS kind of is a little bit more, has more open source roots and was an earlier thing. There's a wider set of open source tooling, and there's actually like a fairly wide set of people that are taking a DevOps approach to the identity side there. It's not really all that uncommon of a thing. With Azure, it was a little less common. Over the last 3 years, there's a bunch of, like, almost every tool here that I'm going to show is made by like one of like 3 or 4 guys working at Microsoft that are really pushing this kind of ops-based approach to Entra IAM stuff. And I think with every one of these tools, like, you look at the one, you look at the blog post associated with it, and there's easily like 5 or 6 more you'll find, right? Where I just chose a few of the ones that would fit here, and it really is Microsoft, some other people, and a small set of researchers and other people. It's great, like a huge body of work here to try to start making these things a bit more possible on the Azure side, just because a lot of reasons, a little less just kind of fits with the grain of what Azure is. So first one, this is the SPI there is is service principal. This is a PowerShell. All these are going to be PowerShell, or I think all these are going to be PowerShell. It's a PowerShell utility, and in the Azure world, obviously, like for applications, automated things, service principal is kind of like the right type of identity to use for that sort of thing. In any environment where you have a lot of, there's going to tend to be a ton of these associated with various applications and things like that. One of the number one ways we see people kind of make posture mistakes that open up vulnerabilities for attackers in Azure. A lot of the kind of recent major breaches have involved service principals. Midnight Blizzard, compromising Microsoft. Actually, Microsoft themselves got owned because they didn't handle service principals correctly. They stole some credentials, ended up in a sandbox environment, and then their vector to get into the real production environment was essentially through a misconfigured service principal, more or less from what Microsoft has disclosed. So something that literally gets the people that make Azure, and then in addition to them, many other people here. And so it's just really handy PowerShell command that basically pulls, for a target tenant, all of the service principal things that exist and all the things associated with them. So like for service principals that are powering enterprise applications, the application registration, and just all the things you might want there. It'll export them in a JSON format so you can access them programmatically, and then it does some basic auditing there, which can be very helpful. So useful both for including an automation, right? I think a backdoor, kind of backdoor technique that I stumbled on. I don't think it's particularly new, but if you think of like managed identities in Microsoft, if it's a user-assigned managed identity, not a system one, you're able, I think everyone probably knows like service principal in general, you can add your own credentials to it and then use it for access, right? And pretty much, why the thing that many threat actors do, not particularly fancy. But of course, that's also kind of a bit noisy, right? So if the attacker can find a managed identity that's user assigned in your environment, and they happen to have the ability to assign federated credentials to it, what they can say and do is, instead of adding a password to that managed identity, they can say like, oh, this authenticates with Okta over here, the attacker-controlled Okta instance. And then, so there's no changes to credentials associated with that managed identity. And interestingly, when you actually then log into it, it doesn't show up in the same logs and stuff like this, right? So very, very simple foot gun there, right? You have a managed identity, this user assigned, and you grant an identity, user that you shouldn't, the privilege to do just one thing, which is to add federated identity credentials to it, right? And an attacker who's savvy enough will use that to create a backdoor that's not going to show up in your normal logs here. And you see, like right here, the list of things that it gets. At the very bottom there, application federated identity credentials. I forget if that's actually the title where it is, but you'll find information about the managed identities, the user assigned, and whether they have federated identity credentials, and all of like the many other foot guns that you have in Azure. And critically, you get basically just all the state of these sorts of things in one JSON to apply whatever controls you want to. So very handy thing, and handy especially because, in my view, because it is this kind of programmatic, find all the things. Don't scare you about just the one thread or the something. We're going to get you all the service principal information you could ever want, and then we'll do some analysis on it. But here it is for you to analyze yourself. So very handy for that reason, in my opinion. And that's, I'm not going to mention, so with the Microsoft things, it's the same researchers over and over again. You'll see them in the GitHub things. Julian Hayward is the one who created this one, but you'll kind of see some repeats here. Second thing, very relevant to this kind of like CI/CD approach to trying to get a bit more formal about this stuff, is that there's researchers put together a repo of just the conditional policy access sets, right, and put together in a very structured way, where conditional policy limits things like the way people authenticate and all those sorts of things. And he's put together policy sets for particular situations, like here's the bare minimum you can do, here's like the kind of the thing you should be doing for an admin, as you can see in this screenshot, in a very kind of wide set of conditional access policies. It's maintained, and then critically, it comes with PowerShell scripts for deploying that allow you to do things like actually deploy them in a stage way, right? Like where you set up all your users and you put some of them in kind of normal users, then you put people like executives in like the key users group where if things break, like the business kind of stops potentially, and then you put your IT people and people that would need to fix an issue with the policy in a last group, like IT users. And with the PowerShell utilities in this repo, you can then say, okay, I want to take this policy set, take the one that he recommends here, or alter it for your taste or add some things to it, and then using these PowerShell utilities, as soon as, let's say, it gets committed to source control there, you can roll it out in this staged way, right? And if something goes wrong, say at the first part, right, with the with like the regular users, you can immediately, even automatically, the monitoring catches that, roll it back, right? And no human has even had to, notice it, necessarily even identify the issue or fix it, right? You haven't accidentally locked yourself out, IT people. You haven't locked out, key people running the business out or anything like that. You kind of, in the spirit of these DevOpsy things, identified the problem automatically, remediated it automatically before it was a serious problem. And also just another great example, I think with Parliament, there's a little bit of this, but here too, where great like kind of community of practice around like what are the right things to do when it comes to conditional access policy. I mean, it's not literally a tool in the most but it is like I think one the most. I think for me, one of the most valuable force multipliers that I've found is like here's the repo where people are collaborating on the right sort of policy to have for Azure. Here's like the thing you get to after you get it wrong for months and months and months and find all the edge cases and stuff like that. So another one by one of those kind of the Microsoft researchers. The GitHub URL is down there at the bottom. Pretty straightforward what it is. A great blog post about this ring deployment model that the PowerShell script here uses to deploy these conditional access policies. And in general, I think not something going into in depth here, but a lot of great structure to them, right? Like the division into policy group sets and things like that, where you're not left kind of like, let me look through 400 conditional access policies and try to figure out which ones I want to use. Like lots of structure there, to kind of speed up that process. So then, kind of running through a few more, kind of all on the same theme. This is by I forget, by the guy. I think the utility we saw there last. This is a website of in Azure. There's 1 million roles, 1 million actions, 1 million kind of standard policies, more being added every day. This is actually a constantly updated, programmatically accessible database. It lists all these things, but then critically it does key things like classify them and say, what's the privilege level of this very obscure action that you're never, going to run into potentially, like the user. Exactly, there's a very, very specific action that lets people, create like a backdoor from a managed identity, right? Which is a fairly obscure permission. You could try to secure against things like that by reading all the blog posts, trying to understand everything that exists. Or you can use something like this to say, okay, as of today, does this action, does this role, give someone control plane access, right? And if so, I want to take this action in my policy, right? So kind of lends to that like operational scientific approach there potentially by meaning that you don't have to manually parse every privilege that exists. And a great thing, I love just like going through stuff like this and looking at all the weird privileges that exist, right? In the spirit of understanding what you're defending, right? Because that's, there's no substitute, I think, for really kind of having that deep knowledge. Last thing to mention very quickly, EntraOps is just another one of these PowerShell tools. This one, we talked about the one that fetches all the Azure security principles into a programmatically accessible format. This one does the same thing, except it's with all the identities in the environment, and then critically it maps it into Microsoft's EAM, enterprise access model. So you can actually tune this over time, and it'll say this asset is a control plane asset, this one's a management asset, this one's a data asset. It'll actually categorize users by their privilege level in a way that's kind of scarily accurate, especially as you tune it right. And then you can do very simple things like say, of my users of this sort, like which ones have control plane access, right? Because that's the thing that I don't want to happen. Or some great examples there of saying like, in this case, like which of my guest users have a significant privilege, right? Any query you can think of like that, are possible in PowerShell, and then critically then possible to use CI/CD to enforce constraints there. I don't want guest users to have control plane privilege in my environment ever, And so it's expressed also, going all the way back to the beginning, it's expressed in terms of a rich model there, right? We're using a concept control plane from a framework, as far as like what sorts of privilege matter, and then just expressing kind of a policy constraint there that we don't want external people to have that access, and then that's enforced automatically in code on the body of policy that's in code and being applied to the environment. And I can just, from that point on, I don't have to worry. No matter all the applications in my environment, none of them will ever, no one will be creating a guest user with that control plane access that might allow them to subvert that thing. That application, no application can provision that accidentally in some way because of developer mistake, whatever else. So it's just EntraOps, same sort of thing. Gets to, I apologize, probably paused on the wrong screen there, but same sort of thing as the other ones, is getting this information accessible in a programmatic way. And because it's done by people in Microsoft, like really great job of getting all these things you might not even be aware of exist in all these areas. I won't touch on this too much. This is just, I wanted to make sure I touched on this advertiser thing, the great database of Azure permissions. Same idea, just for all permissions from all clouds. It's a website called permissions.cloud by the author of IAM Live. Includes Google, Azure, AWS, but same idea as that advertiser thing. Here's all the things that exist, classified as far as like, this is one that allows write. This is one that allows, mutate, like, the kind of privilege manipulations and stuff, and sort of, lets you kind of weed through that in an automated way. And finally, just, I think I'll end here, just there's a couple things that didn't really fit the list of things that directly relate to kind of trying to evolve in a DevOpsy kind of way when it comes to IAM sort of stuff in the cloud. But two great resources, the Hacking the Cloud website, great source of like offensive security recipes in the cloud. Great to be thinking of from a Defender perspective. That's like the catalog of techniques people will be using to kind of own the environment. And then in Tidal, created a very kind of still kind of scrappy early stage utility, but for kind of like access in the cloud, across network boundaries, using just AWS primitives. So you can have like an EC2 instance, no public network access, but then from your workstation, get network access to it basically. So I think that's the talk there, and yep, I think I wanted to leave this talk. Thank you. Thank you, John.